Hola Team Bio, this I think is your last screencast of the whole year, so it's been a good run. Okay, so this screencast is, we're going to be exploring the question, what defines a species? And you might think that this is kind of a trivial question, but it's actually much more complicated than you might think. So there are some cases where clearly species are distinct from one another. I'm looking outside right now and I see a tree. What kind of? It's a birch tree, and clearly this birch tree and I are distinct. We are different species, and so when we look back in the history of how scientists define species, it was based on how they look. This is called the morphological species concept. I'm going to actually write that on a new page. Okay, the morphological species concept. Morphology being how something is structured or how something looks. So the morphological species concept says that when two species look similar, then they are, or similar enough, then they are the same species. So for example, all humans have a certain shared set of characteristics that we all have in common. And even though there are differences between us, we share the same basic body plan and 99.999% of the same genome. Therefore, we are the same species. But disregard. For the morphological species concept, we're not looking at DNA. We're just looking at how something looks. So therefore, I guess the converse of the morphological species concept is that organisms that look different from one another are not the same species. And here's where we run into some tricky issues. Okay, so here's an example of some ants, and you might say, wow, these ants look really different. They must be a different species. But actually, these are both female workers, the major and minor type of this harvester ant. So even though they look very different, they are still of the same species, and they carry very, very similar DNA. So the morphological species concept starts to break down when we find species that don't look very similar and yet are the same species. So you might then say, okay, species that look different. Okay, well, I'm just going to give you one more example here. So this brings me to the next point that, okay, grizzly bear, polar bear look very, very, very different. And are found in slightly different parts of the world. Obviously, grizzly bears are found further south than polar bears. But with the advent of climate change, it's been getting warmer in some places, and climates are changing, and the habitats of these two bears actually overlap sometimes. And when this happens, this is what you see. That's right, growler bear cubs. So these cubs are the result of a polar bear mating with this grizzly bear and producing viable cubs, viable babies. So this goes against the morphological species concept. You would think that these two bears, they look so different, and yet they can produce viable offspring. So just looking different isn't always a good definition of what a species is. So let's move on to another definition. This is called the biological species definition. Okay, so the biological species definition, instead of based on what things that look alike, it's defined by a species that are members of a population or populations that actually or potentially interbreed in nature. So this is more of a less of what you look like and more of what is possible. So some species, for example, polar bears and grizzly bears, can reproduce and create biologically sound or viable babies. But some organisms can't. For example, a horse crossed with a donkey creates a mule, which is I guess I should say, these polar bears, these growler bears, are also fertile themselves. These guys, when they grow up, they can have babies. However, other organisms, like a horse and a mule, sorry, I think I said horse and mule, and what I meant to say was horse and donkey. So a horse and a donkey can mate and produce viable offspring, which are mules. So these guys will have mules, which is kind of a combination of a horse and a donkey. But mules are not fertile. And because of this, we can consider horses and donkeys to be distinct species because they do not make, although they make viable offspring, the offspring, mules, are not fertile. But there are two other types of ways we can consider an organism to be distinct species. And this is so horses and mules, I keep saying that, horses and donkeys can have viable offspring but are not fertile. But there are other organisms that, if mated together, they will not produce viable offspring. So this is called a post-zygotic barrier. So two species, if mated together, will not produce a viable offspring. Post-zygotic means the zygote is formed, but it's not supported for, it can't develop into the organism. So this would be a post-zygotic barrier, and it would be the definition of two different species. Another is called a pre-zygotic barrier. And this is when you would never see these two species mating. So we consider them to be two distinct species because they never actually create a zygote. There's some sort of pre-zygotic barrier. For example, two organisms that potentially look very similar but have different breeding times, say one breeds in the fall and the other breeds in the spring, this would be a pre-zygotic barrier to having kids because you're not fertile at the same time, so therefore you cannot interbreed in nature. Another example of a pre-zygotic barrier would be if two species had different mating calls. So a male of a certain species will never attract a female of another species because the mating calls are different. So that, again, is a pre-zygotic barrier. Okay, so I think this is it. We've got our biological species concept, which is that two organisms cannot produce viable offspring, either because they are pre-zygotically or post-zygotically there's a barrier between them of those things, or the morphological species concept, which says if two different organisms look different, then they are considered a different species. And remember, this morphological species concept is good in some situations, but potentially doesn't tell us the whole story. Okay, that is all.